we are going to discuss some important problems in complex numbers for IPE. First, we will discuss very short answer questions. These are 2 marks questions. 2 questions come from these chapters. Okay, 2 questions come from this chapter for IPE. First one is write the complex number two minus 3i into 3 plus 4i in the form of a plus ib. What is the problem? Here the complex number is 2 minus 3i into 3 plus 4i. We have to write this complex number in a plus ib format. That means what? General form of the complex number. We have to write this complex number in general form of complex number. What is your general form? A plus ib. So given complex number is 2 minus 3i into 3 plus 4i. So it is one complex number and this the another complex number. So Z1 into Z2. Multiply these two complex numbers as we discussed in previous videos. 2 into 3, 6. 2 into 4i plus 4i gives 8i. Minus 3i into 3 gives minus 9i. Minus 3i into 4i gives minus 12i square. That is equal to 6 minus 8i minus 9i gives minus I. Minus 12 into I square means minus 1. So 6 minus I minus of minus plus 12. That is equal to 12 plus 6. Real parts. Both are real parts. 6 and 12. So add these real parts. 12 plus 6. 18 minus I. This is in the form of A plus IB. Next problem is write the complex number a minus ib by a plus ib in the form a plus ib. The given complex number is a minus ib by a plus ib. Now, it can be written in the form of a plus ib. So, in the denominator, we have imaginary part. To remove this imaginary part, we have to multiply the denominator with the conjugate of that number, that complex number. What is the conjugate of a plus ib? A minus ib. So multiply numerator and denominator with conjugate of the denominator. The denominator is a plus ib. The conjugate of a plus ib is a minus ib. Multiply numerator and denominator with conjugate of the denominator. Okay. Now a minus ib into a minus ib by a plus ib into a minus ib. Okay. Now multiply the as usually using complex number multiplication. A into a square. A into minus ib minus iab minus ib into a minus iab. It can also be minus iab minus ib into minus ib plus I square b square divided by a plus ib into a minus ib. It is in the form of a plus b into a minus b. What is a plus b into a minus b? A square minus b square. So a plus b into a minus b equal to what? A square minus b square. By using this formula, you can multiply the denominator. A plus a b, a minus b. So a square minus ib square, ib whole square. Okay. That implies a square minus iab minus iab minus iab. So minus 2iab. Okay. Plus I square value is minus 1 b square by a square minus I square into b square, which equal to a square minus 2ab into I minus b square, okay, divided by a square. The value of I square is minus 1, minus into minus gives plus b square, okay. Now which equal to a square minus b square, write real parts together, a square minus b square minus 2ab, it is the imaginary part, 2ab divided by a square plus b square, okay. Now separate the denominator for above two terms, a square real part and imaginary part, a square a minus b square minus 2ab by a square plus b square into I. This is in the form of a plus bi, okay. Problem is write the conjugate of 3 plus 4i into 2 minus 3i. Before find out the conjugate of this complex number, first do the multiplication of these two. It is the product of two complex numbers. So do it first. Multiply these two complex numbers first. 3 into 2, 6. 3 into minus 3i, minus 9i. Now 4i into 2 plus 8i. 4i into minus 3i minus 12i square. 6 minus 9i plus 8i gives minus I. Minus 12 into I square value is minus 1. Now 6 minus I, minus of minus plus 12. 6 plus 12 gives 18 minus I. Now find the conjugate of this. Conjugate of 2 minus 3i is right like this. Conjugate of 8 minus I, which gives 18 plus I. Okay. We find the multiplicative inverse of 7 plus 24i. Let us take z equal to 7 plus 24i. Now, what is z inverse? Multiplicative inverse means z inverse. It can be written as like this. That means 1 by z equal to 1 by 7 plus 24i. Now, it have imaginary part in the denominator. So, multiply the denominator with the conjugate of denominator. That means the conjugate of 7 plus 24i, I is 7 minus 24i. So 7 minus 24i by 7 minus 24i, which equal to 7 minus 24i by 7 plus 24i, 7 minus 24i. It is like a plus b into a minus b. So a square minus b square. 7 square minus 24i whole square. 7 minus 24i by 7 square is 49 minus 24 square means 576 into I square means minus 1. Understood? 24 square is 576 and I square is minus 1. That is equal to 7 minus 24i by 49 minus of minus plus 576. Now, which equal to 7 minus 24i by 49 plus 576 gives what? 576 gives 625. Okay, which equal to 7 by 625 minus 24 by 625. This is the required multiplicative inverse of the given complex number. Okay. The next problem is write the conjugate of 5i by 7 plus i. Here, first we have to convert given 5i by 7 plus I in the form of a plus ib. So multiply numerator and denominator with the conjugate of 7 plus I. What is the conjugate of 7 plus I? 7 minus I. So multiply 7 numerator and denominator with 7 minus I. Okay. Conjugate of 7 plus I is 7 minus I. Multiply numerator and denominator with 7 minus I by 7 minus I. That is equal to 5I into 7 minus I by, now 7 plus I into 7 minus I. 5I into 7 minus I by 7 plus I into 7 minus I. Multiply 5I with 7 minus I. 5I into 7 gives 35I. Minus 5I into minus I gives minus 5I square by 7 plus I into 7 minus I gives 7 square minus I square. That is equal to 35I minus 5 into I square gives minus 1 by 7 square is 49 minus I square is minus 1, which is equal to 35I minus of minus plus 5 by 49 minus of minus plus 1, which equal to 35I by I plus 5 by 50. Now separate this 50 to these two terms. 35I by 50I, 5 by 50. Okay. Now 5, cancellate these two things. 5 1 is 5, 5 tens are 50. No. 1 by 10 plus 5 7 are 35, 5 10 are 50. This is in the form of complex number. Okay. General form of the complex number. Now write the conjugate of given complex number. What is the given complex number? Z. Let us take Z is equal to 5I by 7 plus I. Now what is Z bar? Conjugate of Z means what? Z bar. So Z bar equal to 1 by 10 minus 7 by 10 I. Okay. This is the conjugate of the given complex number. Problem is express the 1 plus I root 3 in modulus amplitude form. Let us suppose Z is equal to 1 plus I root 3. Okay. Z equal to 1 plus I root 3. Now we have to write the modulus amplitude form for this Z. Okay. What is the modulus amplitude form for this Z? Z equal to R into cos theta plus I sin theta. This is the modulus amplitude form. For this, what we have to calculate? R value and theta value. R is what? Modulus of Z. R equal to modulus of Z equal to A square plus B square. Okay. Here what is A? A is real part 1 and B is the imaginary part root 3. So substitute A and B values in this formula. You get square root of 1 square plus root 3 square, which is equal to 1 plus 3, which gives what? Root 4, which equal to 2. R equal to 2. And now we have to find out the theta value. For this, the complex number point is 1 comma root 3 lies in the first quadrant. So what is the theta value in the first quadrant? Theta equal to alpha. That is theta equal to, what is alpha? Tan inverse of modulus B by A. That equal to tan inverse of B by A. B is root 3 divided by 1. That is equal to tan inverse of root 3. Here no negative value, so you can remove modulus. Tan inverse of root 3. What is root 3? You can write instead of root 3 tan 60 degrees. Tan 60 means pi by 3. Pi by 3 means 60 degrees. So tan pi by 3 is root 3. So instead of root 3 you can write tan pi by 3. Now tan inverse of tan gives, tan inverse of tan theta gives theta only. So by using inverse trigonometric formula, tan inverse of tan theta equal to theta. Okay. Therefore, argument theta equal to what? Pi by 3. Now, polar form or modulus amplitude form of the given complex number is Z is equal to R means 2 and cos theta gives cos of pi by 3 plus I sin pi by 3. Okay. Where theta equal to, where R equal to 2 and theta equal to pi by 3. Okay. This is the required modulus amplitude form of the given complex number Z. The next problem is express minus root 3 plus I in the modulus amplitude form. Okay. Now let Z equal to minus root 3 plus I. First we have to find out modulus of Z to write in the polar form. Modulus of Z equal to what? Square root of A square plus B square. What is A? Here A equal to minus root 3 and B equal to 1. A means real part and B means imaginary part. So that is implies minus root 3 whole square plus 1 square, which gives 3 plus 1, which gives what? Root 4. That is equal to 2. R equal to 2. Now we have to find out the argument of Z. Argument of Z. So the point minus root 3 comma 1 lies in second quadrant. Minus root 3 comma 1. This point lies in second quadrant. Okay. In the second quadrant, what is theta? Theta equal to pi minus alpha. In the second quadrant, theta equal to pi minus alpha. That is equal to pi minus alpha means what? Tan inverse modulus of B by A. Okay. That is equal to pi minus tan inverse B by A. What is B? 1 by minus root 3. That is equal to pi minus tan inverse minus the modulus of any number. Negative number also converts as positive number. Modulus converts negative number also into positive number. So minus 1 by root 3 gives 1 by root 3 only. That is equal to pi minus tan inverse 1 by root 3. When you will get 1 by root 3 in tan 30 degrees. Tan 30 degrees means tan pi by 6. Pi by 6. Tan pi by 6 is 1 by root 3. So instead of 1 by root 3 you can write tan pi by 6. That equal to pi minus tan inverse of tan pi by 6 is pi by 6. Why? Because tan inverse of tan theta equal to theta. Tan inverse of tan theta equal to theta. So by using this you get tan inverse of tan pi by 6 equal to pi by 6 only. Pi minus pi by 6. Pi minus pi by 6 means 6 pi minus pi. 6 pi minus pi. Take LCM. 6 pi minus pi means 5 pi by 6. What is the argument? Required argument? 5 pi by 6. Now write in the polar form. That means amplitude form. Modulus amplitude form. Now modulus amplitude form of Z is Z equal to R into cos theta plus I sin theta. Okay. What is R? What is R? 2. R equal to 2. So 2 into cos theta. What is theta? Cos of 5 pi by 6 plus I sin 5 by 6, 5 pi by 6, sorry, 5 pi by 6. Okay, this is the required modulus amplitude form of the complex number, given complex number. Next problem is if Z1 is equal to minus 1, Z2 equal to I, find argument of Z1 by Z2. Here Z1 equal to what? Minus 1. Minus 1 means there is no real imaginary part in this complex number. That means Z1 is purely real number. Purely real. Z1 equal to minus 1 is purely real number. Z2 equal to I. It is a purely imaginary number. There is no real part. So it is purely imaginary number. Before going to this problem, let us discuss some fundamentals about this problem. If Z is equal to 1, that means purely positive real number. Purely positive real number, then it lies on the positive real axis. This point lies on the positive real axis. So, on the positive real axis, what is the argument of this number? 0 degrees. Theta is here 0 degrees. It makes no angle with the positive real axis. So, theta is 0 degrees. Understood? Next, z equal to minus 1. That means it lies on the negative real axis. Minus 1 lies on the negative real axis. The point is minus 1 comma 0. Understood? This lies on the negative real axis. On the negative real axis, it makes 180 degrees with positive real axis. If a complex number lies on the negative real axis, then it makes 180 degrees with positive real axis. Positive real axis, so it makes 180 degrees. So in anti-clockwise direction, so the angle is plus pi. Okay. If z is equal to I, that means it is a purely positive imaginary number. Purely imaginary number. So it lies on the positive imaginary axis. Positive imaginary axis. 0 comma 1. It can be represented as 0 comma 1. Now it makes an angle with the positive real axis. That angle is 90 degrees plus pi by 2 in anti-clockwise direction. Understood? If z equal to minus I, if z equal to minus I, then it can be represented on negative imaginary axis. It can be represented in negative imaginary axis. It makes minus pi by 2 degrees with the positive real axis in clockwise direction. It can be measured in clockwise direction. It is a principal argument, or we are already discussed in previous videos. What is a principal argument? We can calculate the angle in clockwise direction. So minus pi by 2. Okay, minus pi by 2. Now we will come to the problem. Argument of Z1 is argument of minus 1. Minus 1 lies on the negative real axis. So the angle is pi. Argument of Z2. Argument of I. I means the point 0 comma y lies on the positive imaginary axis. So positive imaginary axis makes 90 degrees with positive real axis. So argument of I is pi by 2. Now argument of Z1 by Z2 equal to argument of Z1, sorry, argument of Z1 minus argument of Z2. What is argument of Z1 by Z2? Argument of Z1 minus argument of Z2. What is argument of Z1? Plus pi minus argument of Z2 is pi by 2. So pi minus pi by 2 gives pi by 2. Finally, argument of Z1 by Z2 is what? Pi by 2. This is about this problem. Okay. Next problem, if Z1 is equal to minus 1, Z2 equal to minus I, then find argument of Z1 into Z2. Given Z1 is equal to minus 1. Argument of Z1 is Argument of Z1 is equal to argument of minus 1. Minus 1 is purely real number. It is a Z1 is purely real. So it lies on the real axis. Purely real number. So it lies on the real axis. Minus 1. Minus 1 comma 0. So the point Z1 lies on the negative real axis. On negative real axis, argument of a complex number is pi. Since it makes 180 degrees with the positive real axis in anti-clockwise direction. So what is the argument here? Pi. Okay, so argument of minus 1 is pi. Argument of Z2. Argument of Z2 means what? Argument of minus I. Given Z2 is minus I. So argument of Z2 equal to argument of minus I. So the Z2 lies on negative imaginary axis. 0 comma minus 1. The point is 0 comma minus 1. So Z2 lies on the negative imaginary axis. So it makes this imaginary number. So that means the complex number Z2 makes pi by 2 angle with positive real axis, but it is in clockwise direction. So it can be measured in negative angle. So what is the angle of this point with the positive real axis? Minus pi by 2. Minus pi by 2. Minus I lies on the negative imaginary axis. The negative imaginary axis makes minus pi by 2 angle with positive real axis in clockwise direction. So argument of minus I is minus pi by 2. Now argument of Z1 into Z2 equal to argument of Z1 plus argument of Z2. Remember the formula. Argument of Z1 into Z2 equal to argument of Z1 plus argument of Z2. If it is product of two complex number, then the arguments should be added. Here we have argument of Z1 by Z2, then argument of Z1 minus argument of Z2. You will get minus. Okay. Argument of Z1 into Z2 is argument of Z1 plus argument of Z2. So argument of Z1 is pi, which is minus pi by 2. So pi minus pi by 2 gives pi by 2. Okay.